AC-50 foiling wing sail catamaran. Dynamics controlling the America's Cup. The dynamic system or plant is the AC-35 hydrofoiling catamaran, which was the type of boat raced in the 2017 America's Cup. Lifting bodies, which lie under the waterline, provide enough lift to push the two hulls completely out of the water, allowing for much higher speeds to be reached by the boats, as there is a considerably smaller amount of friction on the body caused by the water. Actuators control these lifting bodies, which are called dagger boards, while sensors provide feedback to the closed-loop dynamic system about the position and attitude of the boat at the current time relative to the Earth-centered inertial frame, allowing for the actuators to make small further adjustments to the rake angle and the dagger board height in order for the boat to reach optimum foiling conditions.
The governing equations of motion are the two equations relating the angular velocity in the x and y directions, which acquire the data from the accelerometer in the daggerboard casing, as well as the transducer, which measures the vertical height of the daggerboard within the case.
The system is continuous, as it is continuously updating the daggerboard to ensure that it is continuously in an optimal position for equilibrium.
What are the inputs to the system? Accelerometers measure the current forces in the x and y directions along the boat to make sure that these are kept constant. If they are changing relative to the time the boat is pitching and will either drive or fly out of the water. Transducers on the boat also measure the current rake angle and daggerboard height to provide a baseline so the dynamic system can make adjustments to these accordingly.
The outputs of the system are adjustments to rake angle and height of the daggerboard in order to keep it at an optimal angle and position. The rake angle can be increased to effectively increase the angle of attack and lift of the boat, or decreased in order to decrease the angle of attack and lift of the boat, forcing it to descend. The height of the daggerboard is only adjusted to make sure that only the minimal amount is in the water to reduce drag.
What is being measured? A transducer measures the rake angle of the daggerboard, which is defined as the angular displacement away from the z-axis in the body reference frame. Furthermore, the transducer also measures the depth of the daggerboard, which is the length that extends under the hull of the boat. Accelerometers placed around the boat measure the force due to gravity relative to the Earth-centered inertial frame in 3 axes and measure the pitch of the boat as well as the rate of the pitch change.
The form of feedback being used is negative feedback, as the desired angle of 0 is input and the desired error from 0 angle is output. This output becomes the adjustment of the control system. Ideally, there will be no adjustment required to the daggerboard, but this is unlikely. When the feedback from the accelerometer is there, a change in the angular position, then an actuator will adjust the daggerboard accordingly.
The controller will be a function of the force of the accelerometer and the values of the transducer. It's a PID controller, and it takes in the input from the accelerometer and the transducer and determines the error from the desired equilibrium based on the rates of motion.
The performance metrics being used are the sampling rate of the transducer and the processing rate of the PID. Also, reaction rate of the servos and actuators once they are given commands, as this will reduce the overshoot of the correction applied, and should theoretically require less correction as the process continues, as the corrections made will be smaller and smaller if the boat is trying to fly at an optimal straight and level configuration.
The 3 coordinate frames that we have are the Earth-centered inertial frame, or the east-north up, which is the inertial frame for this system, the body frame, which is the frame of the boat and rotates relative to the water and earth, and finally the daggerboard frame, which rotates relative to the body frame of the boat.
And provided here is a schematic block diagram of the system, which outputs the error and creates the adjustment.